Hi everyone, my name is Dr. Kristen Vogt, and I am the Director of STEAM and Innovation for the Pathway to Adventure Council, the Boy Scouts of America. And in here, just for you guys today, we are going to be doing a quick experiment about foam. So before we begin, a few safety measures. Number one, make sure that when you're working with foam and water, because this is going to be a water-based activity, make sure you've got like a tray or something else that can catch water. Because I don't know about you guys, but my least favorite part about doing science experiments is cleaning up. Additionally, some of the stuff may get a little sticky, so just be careful. And then finally, I kind of said it before, make sure you clean up everything afterwards, because even though we're working with a ton of soap in this experiment, some of the soap can be a little sticky or it may be weird on certain surfaces. Always make sure that you're doing this on a surface that can be easily cleaned. Notice how I'm doing this, not only just in the tray, but I'm doing this in the comfort of my dining room, which can easily be cleaned due to the wood floors, but don't do this on like, carpet or your bed or something like that. Let's get started. So this experiment is about testing out different types of liquid soaps to see what kind of foam they make. So, does anybody here know what foam is? I know for a fact you guys have probably played with it in some cases. So, for instance, how many of you have, for instance, played in a bubble bath that was filled with wonderful bubbles? That's a great example of foam. Another good example where sometimes foam isn't always liquid, so we also think of things like foamy heads of soda, or maybe a milkshake, maybe even something like whipped cream that's a type of foam. Foam doesn't have to be liquid. For instance, a bath sponge is also considered a foam. So what a foam technically is, it's an object formed by trapping pockets of air pockets of air or pockets of gas in a liquid or a solid. So anytime there's a whole bunch of pockets of something, pockets of gas, pockets of air, that is going to, and it's covered within a liquid or a solid, that's going to create foam. So solid forms can be closed or open. So enclosed, that means it makes the pockets and it keeps surrounding the material. So the foam that we're going to make today, for the most part, is going to be closed cell, but there's going to be some open cells as well. Open cell is when the gas pockets form to each other and they make each other bigger too. So for instance, if water flow easily throws through the entire structure, like say, a sponge that you're cleaning with, that would be another great example of an open cell. And a mat, so for instance, either a mat you might use for camping, like many of our camping adventures, that's another example of closed cell, or maybe a yoga mat too. Anything where they can be closed and that nothing's gonna get them in. Now, I'm sure you guys are even thinking like edible foam, like honeycomb, if you've had that type of candy before, or any of the really crunchy kind. That's another great example of a foam that you can actually eat because it's trapped particles of air inside of a solid surface. And one scale that we use to measure foam is a bubble. So how big are the bubbles going to get? And this is where our science experiment is going to be today. So in front of me are a bunch of clear cups, because I want you guys to see what we got here. Each one of these is a teaspoon. So of the materials you're going to need today, I used a tablespoon. This is a tablespoon. A tablespoon each of, this one is dish soap. This one is, if you can see here, I promise you, this is not Parmesan cheese, grated Parmesan cheese. This is actually hand soap, goat hand soap, made from one of my friends in Nebraska who runs an awesome goat farm. Her name's Jenny. I'll put her information at the bottom if you want to buy some awesome goat soap. This one at the bottom is, this one was hand soap. This one's hand soap. This one here is actually Glycerin. In addition to being an awesome song from the 90s for my moms who are watching out there, Glycerin is a type of fat product. It's usually what you see in bubble baths. It also doesn't have a smell. And then finally, my little cheat one here, this is shaving cream. Shaving cream's already in a foam form, and the experiment we're gonna do today is, well, when each one of these liquid cleaning products, when each one of them meets with water, what happens? Does it create foam? And if we've got enough time, we might be able to even make more foam. So let's get started. Another thing you're going to need is a 1/3 of a cup, and you're also going to need some water. And in addition to this, you're going to need a spoon for each one of these glasses. The reason why I'm not using the same spoon in each one is because I don't want to contaminate the different variables. Contaminate means that you're dipping from one variable, meaning each different glass. You're dipping from one to the next, and that can contaminate it, meaning you're going to make it not have the same reaction. And ultimately, with a science project, you want it all to have the same reaction, or at least a similar reaction. You don't want to say, okay, this one, there was a little bit of dish soap in there, but it's still fine. So what we're going to do first, notice how I'm putting this in here. So this way, no spillage. So there goes the dish soap, and for, let's see, 10 seconds, I'm going to stir it. So is there any foam forming? Do we see foam? There's a little bit of foam forming at the very top. Little bit. Next one we're going to test out is going to be my hand soap. Now, hand soap has a lot of this one has a lot of animal fat in it because, as I mentioned before, it's made with goat's milk. So I think this one's going to have much more of an effect because fat, also known as a lipid, is probably going to trap more bubbles in it. It's kind of looking like lemonade. By the way, a lot of times in science, you may think something looks like a food product. Don't eat it. Do not eat it. Ooh, whoa, this is nice and foamy. All right. And so with this one, it looks like this one may have folded out. So what I'm going to do here is fill this in again. Thought it felt good. So once again, notice how with each one, I am filling it with the same amount of water. And with each spoon, I'm putting it in order inside of the tray. So this way I know which one goes into each cup. Something you can also do is label each one as well. So, whoa, stirring. Also, if you've got the time, I recommend looking at the back of each one of your each one of these guys. I recommend looking at each one of your products. Maybe some of them may have similar ingredients inside of it. As a result, sometimes they may have similar effects because of the chemical equations and the ingredients inside of it. So with this one, this is glycerin. So additionally, if you're working with some of these, you're probably noticing, ooh, it smells really nice. Now, as a scientist, or when you're conducting any scientific experiments within chemistry, always remember, never directly smell something that you're working on in an experiment. There can be a bunch of bad things that happen if you do that. So instead, what you're going to want to do is something called wafting. So go like this. So this way, the direct product isn't going right into your nose and mouth. So a lot of times it can be safe, but sometimes if you're working with a product that, you know, is really heavily in something like alcohol or something like that, it can have a not good effect on you. But in this case, waft. In this case, I mean, that smells like dish soap, so nothing to really worry about there. So, but back onto the glycerin. Let's get back to you, glycerin. Whoa, this one is getting really foamy. And if you can see over here, if you can see, the bubbles are even bigger. So, and now we're gonna end with my little cheater, my shaving cream. Part of the reason why shaving cream works in that way is because there's so many bubbles trapped inside, because it's easier to spread on human skin as a result. Some people actually don't like using shaving cream for that reason. They say it dries their skin out. Oh, this is interesting. So even though it was plenty nice and foamy, it didn't have the same reaction as the other soaps did. In fact, oh no, my pretty foam is actually, it went flat. I thought the opposite would happen. I thought, you know, maybe by putting more water in it, that maybe the foam would get even foamier. But the challenge when you're working with a lot of solid solid forms of foam, sometimes water can actually have another effect on it. In this case, it made it flatten. It basically watered it out, no pun intended. I try to stay away from puns in this one. So let's take a look at my foam. And so we've got, this actually looks like a foamy apple juice. This is what happens. So this one was my this was my dish soap. As we can see, there's a tiny bit of foam, tiny bit of bubbles. Here we have this one was the hand soap. With the hand soap, this one definitely had some foam at first. There's definitely some foamy action, but the foam bubbles didn't stay there. There wasn't enough lipid activity. There wasn't enough, meaning there wasn't enough fat activity. There wasn't enough of that going on to really catch those bubbles, to keep them going, which actually is not a terribly bad thing to have if it's something that's going to be in constant contact with human skin. I mean, much as we all love bubbles in our bath, imagine how annoying that would be if you're just like, oh, I cannot get these bubbles off my hands. Then right here, we've got the hand soap, same deal, the liquid hand soap. Once again, just like the bar hand soap, it had the same reaction where there is a little bit of foam, there is a little bit of bubbles, but at the same time, it kind of fell apart. But this makes perfect sense if you are designing a chemical that is going to be routinely going on a person. You want something that's going to stay there for a little bit, get it nice and foamy. And I don't know if you guys have studied this while we've all been in quarantine, but a lot of times you really don't need a lot of foam in order to get your hands super clean. It's actually a psychosomatic, meaning it's something that plays in our heads. It's a psychosomatic reaction when we think, okay, I'm getting nice and clean. Look at all these bubbles. In our heads, we think clean bubbles. And speaking of bubbles, my glycerin may be the winner here, because glycerin got a nice little crown right here, and the bubbles, which I don't know if you can quite see them, are really big. Now, glycerin doesn't have a smell, and I should mention this is vegetable glycerin. So glycerin doesn't really have a smell. It actually feels kind of filmy if you work with it. So for instance, in Boy Scouts, we do a lot of activities with bubble science, which is so much fun. But a big challenge is that glycerin, it stays on you. It's like vegetable oil. In fact, there's a lot of similarities between vegetable oil and glycerin. And as pretty as these bubbles are, and as great as they are for making bubbles, like those big fat bubbles you might see at festivals, I don't know if I'd want to wash my hands with glycerin, because I don't know about you guys, I don't like sticky fingers. And speaking of sticky, oh no, look at this is my poor shaving cream. It's separated. Yeah, I mean, on the one hand, we've got this nice thing of foam, but at the same time, another difference that you may see here, when you test this out, another difference is that the shaving cream, the bubbles are very, very tiny, as opposed to the glycerin, where the glycerin was able to trap it. This really makes a wonderful foam because it's able to trap that air and make those big fat bubbles. And those are the ones that we really enjoy working with. So a few things that I want you guys to know also about the several conditions that we do need to make foam. One of them is mechanical work. So me stirring and creating that tension with the water and the liquid or the soap that I used and all these different ones, that was the mechanical work. Surface active components, and those reduce surface tension. Surface tension is when something's like at the top and then all of a sudden there's something going on. So in this case, we've got the water and we've got the different types of soaps. And the formation of foam has to be faster than its breakdown. So in this case, going really, really fast is gonna whip it up and it's gonna make some good foam. If I was slowly stirring the foam, probably not gonna have the same effect. And ultimately, I'm not going to throw a physics equation at you guys, but I will throw it at the end of this if you guys are interested in downloading that material. The actual physics equation to creating foam is about how work is needed to increase the surface area and where there is surface tension. So if you are interested in this, by the way, hopefully the dog is not going to get involved in this. If you are interested in this, some of the more information is from Wire and Hutzler, which is the physics of foam. Believe it or not, this is actually a pretty heavy physics equation that a lot of people have to think about. In fact, believe it or not, in a lot of factories in which products are made, chemical foams can be a huge problem, because think about the foam not being able to break now. Now imagine you're in an environment where the foam can't be broken down. Do you throw it out? Do you wash it down? How do you get rid of foam? And this is something that, if you're interested, a lot of scientists and engineers actually work on this on a regular basis. So this is one of our many careers that we look at in Boy Scouts and with the Exploring program. So if you are interested in this, if you're interested in either exploring a potential career in either science, technology, engineering, math, or arts, please check us out. Check us out on our website at pathwaytoadventure.org, or shoot us an email with me at kristen.vote@scouting.org. We love to hear from you guys. Thank you guys so much. Have fun and be safe.